Okay, so today we're going to have lesson 6.2, and lesson 6.2 is all going to be about taking word problems that are exponential functions and how we're going to solve those. First video is going to be on writing exponential functions for just your general type of an exponential function, and then we're going to talk about a specific exponential function that has us calculate compound interest. Okay, so starting out then. Writing exponential equations. So we're talking about a parent function. We said that was y equals a times b to the x power. So that is an exponential function. Now, each of those parts, the y, the a, the b, and the x, all have a specific function. First off, our b is what we called our base. Okay? So this b value here was our base. Now, what that base is that base is going to represent your rate of change. So it's kind of like your slope, except slope on a line increases at a constant rate, okay? And your slope, your rate of change on this exponential function does not increase at a constant rate. It increases more rapidly, which is what causes it to have a sharp curve, okay? But that is still technically our rate of change is our b. Okay, your x value, that's our input value. And typically, when you're dealing with exponential functions, it is going to refer to time. Okay, so almost always, anytime we are solving that is going to be referring to time. Okay, now your a and your y have a relationship. I told you guys to just kind of ignore the a when we were just graphing these things and doing shifts. But that a now is going to come into play. The a is going to be your start value. Okay, so whatever you begin with is going to be your A value. And then the last thing, the y is just our output, and that y is going to end up being our in value. Whoops, did not mean to move that. But anyway, so your y ends up being your in value. So essentially, the standard form, or what we're going to be looking for in our word problem, is this right here. We're going to be looking for our start value. We're going to be looking for our end value. Is there a time that's given? What is the rate of change? Okay? So, starting off, let's go through a couple examples here. I've got in 2010, the population of Phoenix was 1,445,632. By 2015, it was estimated to be 1,563,025. Write an exponential function that can be used to model the population of Phoenix in terms of numbers of years since 2010. Now, the first thing that we have to look at on this is a lot of you guys are going to want to give an answer. But I want you guys to see this right now. The only thing the question has asked you to do is to write an exponential function. Okay? So our exponential function is going to be something like y equals 2 times 3 to the x power. This is what our answers are going to look like. Okay? We're going to be giving an equation. The only thing they're asking you to do is give an equation. Okay? Now, after we work on giving that equation, then they might ask you some questions that will require you to solve it. But for now, we are just working on writing this equation. Okay? It's not going to look as simple as that also. So, reading through this question, what do I know? What do I know about this problem? Well, it says in 2010, the population of Phoenix was 1,445,632. It also says that by 2015, the population was 1,563,025. Okay? So, we're talking about population, right? So, I told you guys that there would be an end value and a start value. And it looks like we found our end value and our start value. So A, which is our start, what did this population start out at? 1,445,632. Okay? And then we also know our y value, because remember your y value was your end value. And this ended at 1,563,025. Okay, so we've established that's what those two are. Okay, what other information did it give? It doesn't give us a rate of change. So we're going to have to find that rate of change. Does it give us a time? Well, it gives us this 2010, and it gives us 2015. So how much time has passed? We can find our x, but in order to find our x, we've got to figure out how much time has passed. So how much time has passed between 2015 and 2010? Well, I can subtract those two, and I will see that 5 years has passed. My time is going to be 5 years. So essentially what I'm going to do is I'm going to remember back to the last slide and this equation that we have here, and I'm just going to plug this in. What's my end value? What's my start value? What's my time? And that will leave my rate of change. Remember, when we were trying to solve this thing, we were trying to get it into y equals 2 times 3 to the x power or something like that. Oops, sorry, I realize you guys can't see what I wrote, half of that. So we were trying to get it into y equals 2 times 3x. So we know our start value for our answer. We found it. Okay? I don't need to know my end. I don't need to know my y. I'm trying to make a function. What I'm trying to find here is I'm trying to find that rate of change. Okay? So I'm going to plug all of these values in to my standard form. So my y, 1,563,025, that's my y there, equals my start value, 1,445,632. Okay? And then I don't know what my b value is. That's what I'm looking for. I don't know what my b value is. And my time, we're going to plug that in as a 5. Okay, so I'm taking each of those numbers up there. My start value got plugged in for my A. Okay, my end value got plugged in for my Y. My time got plugged in there. And we're looking for our B. So what do I need to do to solve this? Okay, I've got 1,445,000 blah, blah, blah times B to the 5th power. The first thing I need to do before I can get rid of an exponent, I got to get rid of this number in front. So how can I get rid of that number? Well, I can divide by that number. 1,445,632. I've got to do the same over here. 1,445,632. Okay. When I do that, you're going to get a decimal, and it's okay to get that decimal. I would round it to like 3 decimal places. The more you round it, the more accurate your number is going to be. So it's kind of up to you guys on how much. When I divide that, I get 1 point, oops, wrong color. I get 1.081, okay? And that equals B to the 5th power. Now what do I do to get rid of that 5th power? Well, if you guys remember back to our roots, okay? If you've got something to the 5th power, the opposite of that would be the 5th root. So we're going to take the 5th root of 1.081. Use my calculator. I'm going to enter in that 5 first. Then I hit that second square root with the little x up above it. I get 1.081. Underneath it, press enter, and when I do that, I find that my b value, wrong color again, sorry. When I do that, I find that my b value is 1.0156, so I can round that up to 1.016. Okay, so my answer for this, I now know my b value, and I already knew my start value. The y and the x we're leaving there, because remember we're making a function, so I need an input so that I can find an output. So my answer is y equals 1,445,632, okay? And then times, or I can put it in parentheses. A lot of times they'll put it in parentheses, and I didn't leave myself enough room. Y equals 1,445,632, and then in parentheses, or times that, we've got 1.016 to the x power. And that is our exponential function that we're representing. So what I can do in the future is, let's say somebody says, okay, so this data was from 2010, 2015. Let's estimate what the population is in 2020. Okay, well, 2020 would be 10 years in the future because we started here. So 10 years in the future, what's our population? Well, if I wanted to do that, I would then just need to plug a 10 in for my x. And I would just plug that number in the calculator, and it would give you an estimation of what the population was. Okay? So hopefully you guys feel okay with that there. I'm going to show you guys one other problem that has a trick. Just remember when you're doing these, you want to find your start, your end, and your time. That will let you find your b-value, and then you plug your start and your b-value in. Okay? So the one trick that will happen with this is going to be talking about half-life. Okay? So what does half-life mean? Well, half-life means after a certain time, half remains. Okay? So if I read through this, they say the half-life of unumbium is 10 seconds. Okay? Find an exponential function to represent the percentage of unumbium left after x seconds if you start with 100 pounds of unumbium. Okay? So I'm looking down through, what do I see? Well, the first thing that stuck out to me was right here at the beginning. I start with 100 pounds. So my starting value, my A, is 100. Okay, the other thing I saw up there, I saw something referring to seconds. Well, seconds, that's going to be referring to my time. So that means my x is going to be 10. There's no other information that they gave me, though, right? Because they didn't give me my n value so that I can find my rate. Some people will see half-life and say, oh, okay, the half-life then is going to be a half. Your rate, they know the rate of change, so they're going to say it's 1/2. And that's not actually the case because they give us these seconds here. Okay? So I can't just assume that it's a half if I'm talking about 10 seconds of it. But I am going to use that half-life there to help me figure out what my n value is. So my y value, my n value, if I start with 100, after 10 seconds, how much is left? If I start with 100 after 10 seconds, half of it will be left. So I do know my n value. My n value for this is 50 because half of it remains. So I'm going to plug that into my equation. Y equals A times B to the x power. Go ahead and plug in. I've got 50 equals my A, which is 100, times my B, which I don't know, to the 10th power. Okay? I need to go ahead and solve this thing then. So to solve it, I need to get rid of that number in front. I'm going to divide by 100. That gives me 0.5 or 1/2. Okay? B to the 10th power. How do I get rid of the 10th power? Remember back to our roots. I'm going to have to use the 10th root to figure that out. And I've got to do that to both sides. So I end up with B equals the 10th root of 0.5. Again, if you're using your calculator, make sure you put the 10 in. Then hit the second square root with the x. And I've got a 0.5 in the middle. And I end up with 0.933. 0.933. Okay? So, again, now I know my start value. And now I know my b value. I found my rate of change. So I'm ready to plug in for my answer. Y equals 100 times 0.933 to the x power. And again, say they wanted to know, well, how much of this substance will be left after a minute? Well, a minute would be the same as 60 seconds. So I plug in 60 for my x, plug that in my calculator, and find out what my answer is. Okay? But that is our answer for right there, because all they want to know is they want us to find the exponential function. And that is that exponential function.